All right, so we're going to introduce two concepts today. One concept is the equation for speed, and then we'll look at the equation for acceleration. So the first thing we'll look at some questions where we're going to examine how to calculate speed, distance, and time. So the equation for speed is speed, which I'm going to write as v, is equal to distance over time. So if you're into those magic triangles, it looks something like this, where you have the relationship between d, v, and t. So let's look at one question here, where we have a car traveling at 450 meters in 30 seconds. We're going to calculate the speed of this car. So always write down what you got. So we have the distance, 450 meters. We have the time, 30 seconds, and we're looking for the speed. So the speed is d over t. So in this case, we have 450 meters over 30 seconds. That gives us a speed of 15 meters per second. Now, one common conversion is to go from meters per second to kilometers per hour, or vice versa. So let's take a look at that. So we have 15 meters per second, and we want to convert that into kilometers per hour. So the speed is 15 meters per second. So we're going to convert that. So we have 15 meters per second. So what I'm going to do is I'm going to convert the denominator into kilometers. So that would be 1 kilometer for every 1,000 meters. And then we're going to convert, so that will convert the denominator into kilometers. And then we're going to convert the unit of time. So from seconds to hours. That will give us 1 hour is equivalent to 3,600 seconds. So what you have here is you have 15 times 1 over 1,000 divided by 1 over 3,600, which basically is the same thing as, if you cancel this out, it will be the same thing as multiplying by 3,600 over 1,000, or simply 3.6. So to go from meters per second to kilometers per hour, you have to multiply by 3.6. Conversely, if you want to go from kilometers per hour to meters per second, it's the opposite, in which case you would have to divide by 3.6. So then the answer becomes 15 times 3.6. That would be 15 times 3 is 45, and 0.6 of 15 is 9. So that's 54 kilometers per hour. Okay, so that's a very basic conversion that probably may come up quite often. Let's look at another example where we have an equation where we could use speed. So look at this one here. We have a swimmer. The speed is 0.8 meters per second. So 0.8 meters per second. The distance is 50 meters, and we want to know how long it takes for this person to travel that distance. For some reason their b disappeared. Okay, so remember the relationship is this. Here's your magic triangle. We're looking for time. Time is distance over speed. So 50 meters over 0.8 meters per second. That will give us a time of 50 divided by 0.8 should be about 62.5 seconds. All right, so that's two questions down. Let's look at the third one. Third question, we have a plane. Okay, you see a plane is traveling at one speed for 2 hours and then at a different speed for 5 hours. We're going to figure out the distance. So the total distance is going to be the sum of the distance for one interval of time plus the second interval of time. In the first interval of time, we have basically a speed of 500 kilometers per hour. So remember, distance is v times t. So in this case, it's going to be, for the first interval, is going to be 500 times 2 hours. So that would give us a distance of 1,000 kilometers. For the second interval, it'll be 700 kilometers per hour times 5 hours, which will give us a distance of 3,500 kilometers. So then our total distance is going to be d1 plus d2, which is 1,000 plus 3,500, which equals 4,500 kilometers. Okay, let's look at a different question, also having to do with a plane, but this one highlights the importance of what's known as average velocity. So average velocity is not just simply the velocities added up and then divided by the number of velocities. So in this case, we have, for example, 4 different velocities. The average will not be simply the average of these 4 numbers because we don't know the interval of time for each velocity. So when you look at average velocity, it's simply defined as, so if I write, for example, v average, just to remind me it's average velocity, it's just simply the total distance over the total time. So in this case, it would be the total distance of 600 kilometers over the total time of 75 minutes. Now, 75 minutes is really, it's unusual probably to think of time speed as kilometers per minute, although nothing wrong with that. But usually it's kilometers per hour. So this would be the same as 1.25 hours. So then, in this case, the average velocity would be 480 kilometers per hour. So it's not the average of the numbers of velocities, it's the actual average of just the total distance over the total time. If you had a scenario where a plane is traveling with a speed of 400 kilometers per hour, for instance, for maybe 2 hours, and then maybe 600 kilometers per hour for 2 hours, then you can go ahead and take the average of those values, because in this case, the amount of time for each velocity is equal. But if it's not, then you have to do total distance over total time. So keep that in mind. Okay, let's look at another example with speed. So let's look at this question. So in this question here, number 10, we have 2 football players running towards each other. So this question involves speed, but it's a bit tricky because what you have is you have one football player running towards another football player. Now, the distance between the football players is 30 meters. So player A has a speed of 9 meters per second, and player B has a speed of 8.4 meters per second. So let's look at player A. Player A is going to travel a distance, which we're going to call d. And the distance they're going to travel is a function of how fast they're traveling, which is their speed, times the amount of time they're traveling. So this is simply the equation d equals v times t. Now, logic. If player A travels a distance of d, so let's say this represents d, then player B must travel a distance of 30 minus the d. The total distance is 30 meters, so when they meet, they would have both covered 30 meters in total, not each, in total. So if D, for instance, so if player A covers, for example, 12 meters, that means player B must have traveled 18 meters. So if we look at player B, the equation for B then would be 30 minus D, that's the distance they travel, is equal to their speed, which is 8.4 times the time. This is an example of where you can just substitute. So we can put equation 1 into equation 2 because we have what D essentially is, which is 9t. So we can do a substitution. So we have 30 minus D, but D is 9t is equal to 8.4t. That will allow us then to isolate for t. If we bring t to the other side, it ends up being 17.4t. And then when you solve for time, you get about 1.7 seconds. So they will meet after 1.7 seconds. Then you can figure out how far they travel by simply plugging in their time back into the equation. So if you want to know how far player A traveled, it would be 9 times their time, which is 1.7. Okay, those are some basic questions involving just simply speed, distance, and time. Let's look at scenarios with acceleration. So scenarios with acceleration, so acceleration means that the speed is not the same. There is a change in speed, and it's defined as A is equal to the final speed minus the initial speed over the time, or basically the change in speed over the change in time. So the thing about acceleration is we could use acceleration in our equations to figure out questions such as how much distance will a car travel when there is acceleration involved. So let's take a look at a question like this. You have a car, says accelerating at a rate of 4 meters per second squared. So we have A. We're given A. A equals 4. We're told that the final speed is 40 meters per second. We're also told the initial speed. The initial speed says it's at rest, which means it's initially not moving. So what we're going to look for is we're going to look for time. So let's look for time. Time, if we rearrange this equation, is VF minus VI over A. So we can figure out how long it takes to accelerate from rest to 40 meters per second. So the final speed is 40. The initial speed is 0. The acceleration is 4. This indicates that it will take 10 seconds to get from 0 meters per second rest to 4 meters per second at that acceleration. Now, if we apply the equation for distance, where distance equals speed times time, we could think about the speed of this object, but we have to think about the average speed of this object. If you understand that the object is traveling initially at rest and then accelerating to up to 40 meters per second, we can assume that the change in speed is constant. So what that means is that if you were to look at a graph of v and t, the velocity, or sorry, the speed is increasing at a constant rate. If that's the case, what you could do is take the average of the two values, because we're spending equal amount of time at basically each slice of, so you can think of like saying, you can look at different segments of time in this equation where each interval of time is the same. So the amount of time spent at 5 meters per second is the same as the amount of time spent at 10 meters per second, which is the same as the amount of time spent at 20 meters per second. Therefore, if the intervals are the same for time, we could take the average. We could take the average of 40 and 0, which is 20. So there's your V average, 20 times the time, which we now know is 10 seconds. And that'll give us an answer of 200 meters. So there's your answer. 200 meters for a car that is accelerating at a rate of 4 meters per second squared. Now there's other equations you could use for acceleration. I'll show you basically another one. Now the other one is actually a combined equation, which I'm not going to derive here for you, but it's combined equation for this acceleration equation with the formula for distance. So remember, distance is simply speed times time. We'll talk about velocity later on. But now we're going to factor in the acceleration. So I'm not going to derive it here in this video for you, but this is the equation for an object that's moving, where you have an initial speed, but you also have acceleration. So this is actually a combined equation with the d equals v times t, which is basically the rearranged speed equation, with the acceleration equation. But this is the initial speed, so I'm going to put a little I here just to remind me that's the initial speed. Okay. So let's look at question number 9, okay? We have a car where it's traveling initially at 20 meters per second, and we know that it's just the car above, so the acceleration is still the same. So the acceleration is 4 meters per second squared. The final speed is 30 meters per second, and we're looking for the distance. Okay, so there's actually many ways to solve this one question. One is we could use this new formula. So let's use this new formula. So we have d equals your initial speed, which is 20 times time plus 1/2 of 4 times time squared. But we don't have the time. But we can figure out the time. We know that the time is how long it takes to go from 20 to 30 meters per second with the acceleration of 4. So we could figure out how long it takes as a function of Vf, which is 30, minus Vi, which is 20, over A, which is 4. This is 2.5 seconds. So now we can plug in our time. So d equals 20 times 2.5 plus 1/2 of 4 times 2.5 squared. So that would be 20 times 2.5 is 50 plus 2.5 squared, I believe, is 6.25. And 1/2 of 4 is 2, so it should be 2 times 6.25. So that would be 50 plus 12.5. 50 plus 12.5 is 62.5 meters. Now, there's more than one way of doing this question. Now, another way we could think of this question is using average speed. Because, as I mentioned, we can think of the cars spending an equal amount of time at the different speeds. So as the car is going from 20 meters per second or 30 meters per second, we can think of at every moment in time the amount is going to be the same. So at 22 meters per second, it's the same interval time as 24 meters per second. So in this case, we can think of an average speed. So we could say that the average speed times the time would also give us a distance. But in this case, it has to be the average of the two intervals, 20 and 30, which is 25 times, and the interval of time was 2.5 seconds. And that will also give us an answer of 62.5 meters. There is another equation we could use, and I'll give myself a little bit of room here so you could see that. So, just give me 1 second here. Oops, sorry. All right, being a little finicky. All right. Oh, hold on a second. Let me just pause this video so I figure this out. And we're back. Okay. There is a third equation. So, okay. The two equations so far you could use with acceleration. Now, again, this is assuming a constant acceleration where the speed is changing at a constant rate. You can take the average of the two values, okay? So we could do this. We could take the average speed times the time. We could use this equation, which is the combined equation with speed and acceleration. There is a third equation, which looks like this. Vf squared equals Vi squared plus 2AD, which takes into account final speed, initial speed, and acceleration, and distance. So in this case, we're looking for distance. So if I was to rearrange this equation, it would be Vf squared minus Vi squared over 2A equals distance. If we use this equation, your Vf squared is 30. Your Vi squared was 20. Your acceleration is 4. So 2 times 4. And then we solve for D, and you'll get the same answer, which is 62.5. So you have like 3 different ways of solving this question. 3 different formulas. So let's look at another example with acceleration. So let's take a look at this one. Determine the acceleration of a vehicle that covers 100 meters in 10 seconds if you started from rest, okay? So we have distance. We have time. We have Vi. And we're looking for A. So we could do a couple things here. One is we could use the equation for the equation that we looked at before, which is this one. D equals VIT plus half a t squared. The initial speed is 0, so this cancels out, and you're left with D equals 1/2 a t squared. So we have the distance. Distance is 100 meters. So we could rearrange this equation now and solve for A. So A would be 2D over T squared. So the acceleration is 2 times the distance, so 2 times 100 over, 10 seconds? 10 squared. So that would be 200 over 100, which is 2. And we know it's got to be meters per second squared. That's one way. Another way we could have done it is using the concept of the average. So we could say this. We could say, look, speed is equal to distance over time. We have a distance of 100 meters. We have a time of 10 seconds, and that gives us a speed of 10 meters per second. But that's the average speed. If a vehicle is starting at rest, then that would be the average of 0 and some value. So the midpoint is 10. The final speed then has to be 20, because 10 is the average of 0 and 20. So that will give you VF, which is 20, VI, which is 0, and then you have T, which is 10, and in that case you could use the acceleration formula. So I'm just going to finish it off over here to figure out the acceleration. So you have VF, you have VI, and you have T. So VF is 20, VI is 0, time is 10, and you can see that we would get 20 over 10, which is also 2 meters per second squared, which is the same as the other predicted answer. Well, there's just two different ways of solving this question. Now, eventually we will start talking about velocity, where acceleration will become a bit trickier to measure, but for now, we're going to keep things simple. And we're going to use the term deceleration to represent something that's slowing down. Okay? So let's look at an example where acceleration is actually not speeding something up, but slowing it down. So let's take a look at number 11 here, okay? So number 11, you have a car. The initial speed is 50 kilometers per hour. The final speed is 0, because it says it comes to a stop. We have the time, 5 seconds, and we want to know the acceleration. Okay? So, first off, I don't know, you might want to maybe convert this to meters per second. You don't have to, but let's say we convert it to meters per second. We know we have to divide by 3.6. So then that will give us an initial speed, I believe it is 13.7 meters per second. But let's just double check that. Let's ask the calculator. What is 50? All right. Maybe not. Maybe the calculator doesn't want to come up. Oh boy. I think it's frozen. All right. This looks like it's frozen. Fantastic. Okay, hold on a second. Okay, so I'm not going to ask the calculator. I've lost the faith in the calculator. So I think it's about 13.7. Hopefully it is, but otherwise you're going to have to correct this. Okay, so we have converted it to meters per second. So now we have initial speed, final speed, we have time, we're looking for acceleration. Remember, acceleration is VF minus VI over T. So VF is 0, initial is 13.7, hopefully, and the time is about 5. So this will give us, I believe, an answer of about 2. I'm going to round it off to about 2.8, but it's a negative answer. So let me explain what that means. So it's about negative 2.9, 2.8. It's about close to negative 2.8 meters per second squared. Now, the negative sign in this case means that it's slowing down. That's what the deceleration refers to. However, this is a bit of a warning. Don't assume that a negative sign always means that it's slowing down. For now, this is an introduction to the course. We can safely assume that it is. But later on, you will see that a negative sign may actually mean that the object is speeding up. But we will discuss that later, not at this moment. Okay. I think we'll just do one more question with acceleration. And here it is here, okay? So we have a father or whatever, someone driving down Bayview at 60 kilometers per hour. So we have the initial speed is 60 kilometers per hour. Now, the car decelerates. So that, again, we're going to assume that that means negative acceleration. Which is, in this case, negative 4 meters per second. The car hits another vehicle after 2 seconds. And one of the questions is, how far did they travel? And the other part of the question is, how fast? What was that final speed? I think what I'm going to do first, I'm going to convert this to meters per second, because one of the things in physics you should always look at is the units. You'll notice that we have meters per second squared, but we have a speed of something that's in kilometers per hour. So I'm going to convert this. So I'm going to convert that to meters per second by dividing by 3.6. That will give me an answer of 16.7 meters per second. So I'll make sure that the units are the same. So you can see that we have meters, we have seconds, so we're good. Okay, so let's first off figure out, actually in this case you might want to do the final speed first. That could be easier. So let's do the final speed first. So what's the final speed? We have a formula for acceleration, which is this, Vf minus Vi over t. We could rearrange this and get rid of the t. That gives us At equals Vf minus Vi. And then I could rearrange and isolate for Vf. So Vf would be Vi plus At. Vf is equal to Vi. Now, initial speed is 16.7 meters per second plus A. Now, number A is negative here. Negative 4 times 2. So this will give us 16.7. This is minus 8. So 16.7 minus 8 is about 8.7 meters per second. Now, you'll know that there would be something wrong. If you forgot to put a negative sign here, let's say for argument's sake you forgot, and you left that as a positive, then this number would get bigger. In that case, your answer wouldn't make sense, because now you have a final speed which is greater than the initial speed. Now, unless the person wanted to slam into the other car, then we know we'd have a problem. You know that the answer has to be less. So always check your signs. It's very, very important. Now, for the distance, you can do V average times time. So you could take the average of 16.7 and 8.7. So you can take the average times 2 seconds, or you could plug it into this equation. So, but if you plug it into this equation, keep in mind that your sign is very important. So if this first part is 16.7 times 2, then make sure that you put in a negative sign here when we're dealing with the acceleration. Now, in this case, it looks like the answer is going to be about 12.7 times 2. Should be about just a little bit more than maybe around, I think, 25.4 meters. Okay, ladies, that's basically a really quick intro to acceleration and distance and speed and time. And but if you're still confused, not to worry. This is just an intro. We will be spending lots of time on this stuff. Okay. So, anyways, take care. I hope you're all well. Bye bye.